For decades, we've been mesmerized by robots doing backflips, dancing to music, and performing incredible athletic feats. We'd watch these videos, our jaws would drop, and we'd think, wow, the future is here. But here's the thing, those robots weren't working. They were performing. They were in the wow phase. Well, friends, 2026 changed everything. This is the year robots stopped dancing and started clocking in. This is the year we moved from the wow phase to the work phase. And the implications? They're absolutely staggering. Welcome to Mindcast, where we dive deep into the ideas that are reshaping our world. I'm your host, Will, and today we're exploring what I believe is one of the most pivotal moments in technological history. We're talking about 2026, the year artificial intelligence finally got a body, the year the digital-physical divide collapsed, the year robots became workers, not just wonders. By the end of today's episode, you'll understand why leading AI researchers now believe that physical embodiment isn't just nice to have for artificial intelligence, it's absolutely essential for reaching artificial general intelligence. You'll discover the fascinating battle between two completely different strategies, the Western Alliance's precision approach versus China's volume and velocity strategy. And you'll learn why this shift affects not just factories and warehouses, but the future of work, geopolitics, and maybe even consciousness itself. So let's start with the big picture. What exactly happened in 2026? Well, for decades, artificial intelligence lived in two separate worlds. On one side, you had incredibly smart software. Think ChatGPT, capable of writing poetry and passing bar exams, but trapped in the digital realm. On the other side, you had industrial robots, precise, powerful, but essentially blind. They could weld car parts perfectly, but only if everything was in exactly the right place every single time. 2026 was the year these two worlds finally merged, and the catalyst? Three major announcements that sent shockwaves through the tech industry. First, Hyundai and Boston Dynamics revealed their production-ready Atlas robot, no longer the hydraulic showboat we knew, but an all-electric workhorse ready for factory floors. Second, Google DeepMind announced their partnership with Boston Dynamics, integrating their most advanced AI directly into robotic bodies. And third, from China, we saw AGBot ship 5,000 humanoid robots. Yes, you heard that right, 5,000, marking the first true mass production of intelligent humanoids. But here's where it gets really fascinating. These announcements revealed two completely different philosophies about how to bring AI into the physical world. Let's call them the precision strategy versus the volume strategy. And understanding this split is crucial to understanding what happens next. The Western Alliance, led by Hyundai, Boston Dynamics, DeepMind, and NVIDIA, is going for precision. They're building what I like to call generalist specialists. These are robots that look humanoid and have general capabilities, but they're laser-focused on specific, high-value industrial tasks. Think of Boston Dynamics' new Atlas robot. It can lift 110 pounds, reach 7.5 feet high, and operate in temperatures from -4 to 104 degrees Fahrenheit. But here's the kicker. It's powered by Google's most advanced AI, giving it something previous industrial robots never had, the ability to reason about its environment. Let me give you a concrete example of how revolutionary this is. In the old days, if you wanted a robot to pick up a cup, you had to program every single movement, the trajectory, the grip force, the exact coordinates. If someone moved that cup 2 inches, the robot would grasp at empty air. But with these new vision language action models, you can literally tell the robot, that strut is loose, tighten it. And the robot will locate the strut, identify the problem, select the right tool, apply the correct torque, and verify the result. That's not programming, that's reasoning.
Meanwhile, China is executing what we might call the smartphone strategy, but for robots. Companies like Agibot and Unitree aren't trying to build the perfect robot. They're trying to build robots cheaply and quickly, then improve them through sheer volume of real-world data. Agibot's 5,000 units announcement wasn't actually 5,000 identical robots. It was a portfolio, including wheeled variants, research models, and full humanoids. Brilliant strategy. Use the easier wheeled robots to generate revenue while gathering data to train the harder bipedal walking algorithms.
And then there's Unitree, which absolutely stunned the industry by launching the G1 humanoid robot for roughly $13,800. To put that in perspective, that's less than many cars. They even have a cheaper R1 model for under $5,500. This isn't just cost reduction, it's strategic democratization. By putting affordable robots in university labs worldwide, Unitree is effectively crowdsourcing the research and development needed to solve robotics' hardest problems. Now, you might be wondering, well, this all sounds amazing, but what's the catch? Well, I'm glad you asked, because this brings us to our second key insight, the technical reality. The gap between demo and deployment is still enormous, especially for consumer applications. The perfect example of this came from CES 2026, where LG showcased their CLOID home butler robot. The marketing videos looked incredible, this humanoid robot folding laundry, fetching drinks, the works. But reports from the show floor told a very different story. The robot took 2 whole minutes to fold a single towel and completely struggled with anything more complex than the simplest fabrics. 2 minutes per towel. At that rate, doing a load of laundry would take longer than doing it by hand. This perfectly illustrates what researchers call the great filter for consumer robotics. Factories are challenging, but they're what we might call structured chaos. The lighting is consistent, the parts are standardized, the workflows are predictable. Your living room? That's unstructured chaos. Different lighting throughout the day, objects scattered randomly, pets running around, laundry that's never quite the same. It turns out that managing this complexity is exponentially harder than we thought. But here's what's fascinating. Even the failures are teaching us something profound. In August 2025, Beijing hosted the world's first humanoid robot games. 500 robots from 16 countries competing in everything from sprinting to soccer to kickboxing. And honestly, it was a bit of a disaster. Robots were wobbling, falling over, and in the soccer matches, goalkeepers were collapsing from loss of balance. But here's the thing. China wasn't embarrassed by these failures. They were learning from them at unprecedented scale. This gets to a fundamental difference in philosophy. The Western approach says, perfect it in the lab, then deploy. The Chinese approach says, deploy it imperfectly, then use real-world failure data to improve rapidly. Both strategies have merit, but they're leading to very different outcomes. And sitting in the middle of all this is NVIDIA, providing what might be the most crucial piece of the puzzle, the computational nervous system that makes it all possible. NVIDIA's new Vera Rubin architecture isn't just a faster chip, it's specifically designed for what they call agentic AI workloads. Here's why this matters. A chatbot can take half a second to generate a response, and you won't even notice. But a bipedal robot balancing on one leg, it needs a control loop update in under 10 milliseconds, or it falls over. The Vera Rubin chips, with their dedicated processors for real-time sensor data, finally make truly responsive robotic intelligence possible. And then there's Tesla, pursuing their characteristically maverick approach. While everyone else is forming partnerships and sharing ecosystems, Tesla is going fully vertical, designing their own chips, writing their own software, building their own robots. It's a high-risk, high-reward strategy that could either make them the Apple of robotics or leave them as a cautionary tale about the dangers of going it alone. But here's where we get to the really big question, the one that I think will define the next decade. Why does any of this matter for artificial general intelligence?
Why are leading researchers like Jan LeCun and Demis Hassabis now saying that true intelligence requires a physical body? The answer comes down to something called grounding. Large language models like GPT-4 are incredibly sophisticated at predicting the next word in a sentence, but they've never actually experienced the world. They know that the word apple often follows eat, but they don't understand that an apple has weight, that it falls when dropped, that it has texture and juice. They've read about the world, but they've never lived in it.
Embodied AI learns differently. By controlling a physical body, the AI receives constant feedback from the environment: gravity, friction, inertia, momentum. This creates what researchers call a world model, an internal representation of how physics actually works. And here's the kicker: an AI that can successfully navigate a cluttered room, manipulate novel objects, and recover from unexpected falls has arguably solved harder cognitive problems than an AI that can write poetry or pass the bar exam.
China has explicitly identified this as their path to leapfrog American dominance in AI. Their strategic thinking goes like this: the US leads in large language models, but what if the real path to AGI goes through physical interaction with the world? What if we can bypass text-based intelligence entirely by focusing on embodied sensory-motor intelligence? It's a bold bet, and it's reshaping global competition in ways we're only beginning to understand. The geopolitical implications are staggering. We're looking at what might be the most significant shift in manufacturing since the Industrial Revolution. When Hyundai deploys Atlas robots in their Georgia EV plant by 2028, those robots won't just be building cars. They'll be demonstrating a new model of human-AI collaboration in high-stakes manufacturing environments. When Agibot ships robots to logistics companies, they're not just moving packages, they're gathering data that could determine who controls the future of physical AI. And the labor market effects? They're complex but profound. In the short term, we're seeing labor augmentation, not replacement. These robots are taking over what researchers call the 4D jobs: dull, dirty, dangerous, and dear. Tasks like part sequencing in automotive plants, heavy lifting in warehouses, working in extreme temperatures. These are physically demanding but cognitively simple tasks that have chronically high turnover rates.
But as these vision, language, action models improve, the robots will inevitably move up the skill ladder. The economic model is already shifting from CapEx, buying a machine, to OpEx, hiring a robot. Companies are starting to treat robots as payroll rather than infrastructure, with robotics as a service models that make advanced automation accessible to smaller businesses.
So, what does all this mean for you? Let me give you 3 concrete takeaways that I think everyone needs to understand. First, we're witnessing the emergence of a new category of intelligence, not human intelligence, not traditional AI, but something entirely new, intelligence that's grounded in physical reality. This isn't just a technological shift, it's potentially a new form of consciousness emerging on our planet. Second, the geopolitical implications are massive. We're looking at a new kind of arms race, but instead of nuclear weapons, it's about who controls the infrastructure of physical intelligence. The fact that China can ship thousands of robots while Western companies are still perfecting single units suggests we might be underestimating the power of the fast and imperfect approach. And third, your career, your industry, your daily life, they're all going to be touched by this transformation. But not in the dystopian, robots taking over sense that science fiction prepared us for. Instead, we're looking at a much more nuanced future where humans and intelligent machines collaborate in ways we're only beginning to imagine. The question isn't whether this will affect you, it's how quickly you can adapt and find your place in this new paradigm.
As we wrap up today's deep dive, I want you to remember that 2026 wasn't just another year of technological progress. It was the year that intelligence finally escaped the digital realm and entered the physical world. The year that robots stopped being performers and became participants. The year we moved from asking, "Can machines think?" to "Can thinking machines work alongside us?" The robots of 2026 aren't dancing anymore. They're clocking in, and that changes everything. Thanks for joining me on Mindcast today. If this episode opened your eyes to the profound implications of embodied AI, please subscribe and share it with someone who needs to understand what's coming. The future is being built right now, and the more people who understand it, the better we'll all navigate what's ahead. Until next time, keep questioning, keep learning, and keep your mind open to the incredible possibilities emerging around us.